Okay, this is our new matrix. We have the 1 in its proper location. We need to change our 4, our negative 4, and our positive 19. How do we find an opposition to negative 4? We got to balance the scale. Negative 4 balances with
A positive 4.
positive 4, exactly. So we're going to use the exact same trick that we used here. We'll multiply this row, because this row has the 1 exactly where it needs to go. We'll multiply this row by positive 4 to cancel out that negative 4 and cause a balance. So when we do that, the row multiplies out to become 0, 4, negative 4, and negative 8. When we add that to the top row, our 0 adds to 1 to leave the 1 there, because that's what we want. We don't want that 1 to change, because that's our column that we've already altered. So we're going to take this 1, 0 plus the 1 leaves it as 1. 4 plus negative 4 gives us a 0. That's our balance. Negative 4 plus 3. What does that give us?
Negative 1.
Negative 1, exactly. And then finally, we have negative 2 times positive 4 is negative 8. Negative 8 plus 3 is negative 5. Now that we've done the top row, we need to do the bottom row. Now 4 canceled out and balanced with negative 4. What's going to balance with positive 19?
Negative 19.
Negative 19, exactly. So we'll multiply this whole row by negative 19. 0 times negative 19 is 0. So that stays the same. We haven't changed that first column at all. Negative 19 plus 19 gives us 0. We have our balance. And if you'll notice, the second column of our matrix is now exactly the way we want it. We then have negative 1 times negative 19, which is positive 19, plus negative 14. Now 19 minus 14 is 5. And then finally we have negative 2 times negative 19. That gives us a positive 38. We'll subtract 3 and we get 35. Now, don't be scared if you get big numbers like this. In the end, everything will work out and reduce down to the answers that you're looking for. So now, we have our first two columns exactly as they should be. Our third column, we want to change to be a 0, 0, 1. Do you see any way to change this bottom row so that that 5 becomes a 1?
Divide by 5.
Divide by 5, exactly. So we'll divide it by 5. 5 divided by 5 is 1. What's 35 divided by 5?
7.
7, of course. All right. Now, we have a 1 down here, but look, we have a negative 1 and a negative 1. Our opposing force, our balance, has already been achieved. All we have to do is add this row to the top two rows. So we have 1 plus negative 1 gives us 0, and we have our balance. 7 plus negative 2 gives us 5. 1 plus negative 1 is 0 again. 7 plus negative 5 gives us 2. And so now we have the form we were looking for. Each column has 1, 0, 0, 0, 1, 0, and 0, 0, 1. We have a diagonal of 1s, and everything else is a 0. This is typically called the identity matrix. Whenever you hear someone say, what's the identity? It means, give me a diagonal with 1s, and everything else is 0. Now look over here at our augmented side. We have 2, 5, and 7. Now when we created our first matrix over here, we took the coefficient of each of our variables and we plugged it into the matrix. What if we went backwards? Let's take this and turn them into coefficients. This first column would be x, second column would be y, third column would be z, remember our line is our equal sign, and this fourth column will be our answers. So we have the first column is x. So we have x, 0x, and 0x. Then we have y. 0y, y, 0y. Now you'll notice I put y. 1 times y is just y. I didn't say 1y. You can, but you don't need to. Then we have 0z, 0z, and z. Okay? We have our equals, and we have 2, 5, and 7. Now, 0 times anything gives us 0. So do we have to write 0x at all?
No.
No, we don't. We can go through and erase anything that has a 0. And you'll notice now we have x equals 2, y equals 5, and z equals 7. If you take these numbers and plug them into each one of these equations, you'll discover that this is the solution to all three of those equations. By treating our system of equations as one unit, as a matrix, instead of three different equations, we were able to find all three answers much more quickly. Now, we're about to start on a project where you're going to take this and you're going to try and solve a system of equations. When I tell you, you will get up and join the groups that you had formed yesterday. I put you all into groups for the last lesson. We're going to keep working in those same groups. When you get up and move, not yet, but when you get up and move, you will go to those groups, and at each table you will discover that there is a box. That box has a combination lock. That lock has 3 digits that have to be put in the correct order to be unlocked. I'm going to give each table a different set of a system of equations. You will solve that using the Gauss-Jordan method. And once you have reduced it and found these 3, you will have the combination for that lock. Once you unlock the box, you'll find a fun little surprise inside. So, now I want you to quickly, and as quietly as possible, please move to your different groups and start working. I will answer any questions you have as you start working.